right, so this is lesson 5.2, task 3, and we're going to identify linear function transformations. Transformations of the graph of the parent linear function f of x equals x are shown in red. Complete each sentence to match the transformation of the graph with its function. All right, so we've been looking at how transformations work, and now all we're going to do is look at what the new equation would be. So this is our parent function, f of x equals x, and this one has been shifted down 3. We can see the slope is still 1, so this one's just going to move it. Well, actually, this one's looking at it as a horizontal, so it actually shifted it 3 units to the right. Remember, the horizontal and vertical translations with the parent function with the same slope are going to be the same. All right, so it says choose the function to complete the sentence. All right, so this time the blue one went down 3, so the y-intercept changed, and the slope is up 1 over 2. So it should be 1/2 minus 3. And they're using the f of x because they're just writing it in terms of a different function. So when they're looking at it like this, like usually we would have y equals mx plus b, and this would be your slope, and this is your x, and this is your b. But because we're writing this function in terms of our other function, that's why they're using the f of x here. All right, but it's the same thing. So choose the function to complete the sentence. All right, so this one's going down, so we know it's going to have a negative slope, and it's down 1 over 2, so negative 1/2, and it's shifted up 3, so plus 3 at the end. So negative 1/2, and then plus 3. All right, this time if you look at the red line, you're going to see it's been shifted up 2, so our y-intercept changes. And we're going to go with up 1, 2, 3 over 1 for our slope. So our slope is 3, and our y-intercept is 2. All right, choose the function to complete the sentence. This one has a y-intercept of 3. And let's see what the slope is. So it's going to go up 1, 2 over 1. So 2 over 1, and up 3. All right, this one has been shifted down. Looks like it has the same slope, so that one's just going to be y-intercept of negative 2. And that's it for task 3. Hopefully you see that the transformations of linear functions are not too hard to find. If you have any questions, please let me know. All right, task 4, transformations with real-world functions. Write and graph a function that models Marcy's cell phone cost plan. Marcy pays $40 per month plus $10 per gigabyte of data for her cell phone. Suppose Marcy's cell phone service provider decided to double the per gigabyte charge for using data. Write a function that gives the new monthly cost in terms of the original function. Then describe how the graph of the new function is related to the graph of the original function. Write and graph a function for the original plan. The total monthly cost, C of D, is a function of Marcy's monthly data usage in gigabytes. All right, so remember she's paying $40 a month plus $10 per gigabyte. All right, so her total monthly cost, we're going to call that C of D, cost of data, cost in dollars, here we go, equals your data usage. So $10 per gigabyte times however many gigabytes you use. So D just represents the number of gigabytes you use, plus your monthly fee of $40. So C of D equals $10, or 10D plus 40, and that's shown in the graph below. So you can see here, the original cost, it costs $40 a month for using no data, okay, just to have the cell phone. But for 1 gigabyte of data, you're going to pay 40 plus the 10, which is $50. For 2 gigabytes of data, you're going to pay $60. For 3 gigabytes, you're going to pay $70 and so on. So that's what our function represents here. All right, it says, what is the y-intercept of the graph? Well, in this case, this is y equals mx plus b. The y-intercept is your 40. So that's your initial starting point. So that would be your y-intercept. All right, write and graph a function for the new plan. To write a function, c of 1, for the new total monthly cost as a function of the original total monthly cost, first double the original function. All right, so if you double the original function, that means you're doubling everything. So you're going to put this in parentheses, and you'll have 2 times all of this. That's what it means to double the function. So if we double the whole function, we've multiplied everything by 2. Excuse me. All right, so it says, how is the original graph transformed? All right, so the graph is vertically stretched by a factor of 2. All right, so how do I know it's going to be vertically stretched by a factor of 2? Because if we multiply the whole function by 2, that means your plan is going to cost twice as much, right? So that's what that means. All right. However, multiplying C of D by 2 doubles both the per gigabyte charge and the monthly fee. To get the monthly fee back to 40, subtract 40 from C of 1 of D. So you're going to multiply the whole function by 2, and then you're going to subtract 40, because when you multiply the whole function by 2, remember we doubled the whole thing. So if you double the whole thing, if you put this in parentheses and double it, that means you doubled the 40 too, which means it was 80. We don't want the original cost to be 80. It's still going to be 40, just the gigabytes is going to double. All right, so that's why they are subtracting 40 here, because we doubled the whole function, and then we subtract 40 to get our y-intercept back to 40. All right, that is it. If you have any questions, please let me know.